And if the bacteria were gone from your front yard, all your plants would wither up and die. And insects and tiny worms would swarm all over your house, and it would be like a horror movie. But your biggest problem wouldn't be your digestive and your housing issues. Your biggest problem would be that you would be dead. Because if even one little innocuous microbe developed some immunity to my magical cleaning product, then it could take you down in an afternoon. Because you didn't have any microbes there to help you defend yourself against it. So I'm not really here to talk about microbes that live in our bodies. I want to tell you about microbes that live on Earth. But the analogy is important, because like microbes are important for the healthy functioning of our bodies, they're also really important for the healthy functioning of Earth. One of the things that's getting to be a problem with the way Earth is functioning right now is climate change. Drought is currently wreaking havoc on a lot of our agricultural systems, and erratic precipitation is exacerbating the devastating effects of wildfires. Greenhouse gases such as methane, carbon dioxide, and nitrous oxide in our atmosphere are in higher concentrations than they've been in millennia. And you can account for nearly all the molecules by the fossil fuels that we've been pulling out of the ground since the Industrial Revolution. So yeah, it's our fault. But if microbes can help to make our bodies healthy, then maybe they can be part of our solution for making the environment healthy as well. There are some microbes that can actually use greenhouse gases and pull them down to better levels, and possibly in ways that we don't even know about. There are microbes that can make crops drought resistant without having to use genetic modification to do it. And there are microbes that can help our forests to recover from wildfires too. So now more than ever is the time to really start figuring out what's happening with all these invisible little creatures that share the earth with us. Now you may think to yourself, I'm not an expert in microbiology, but there probably is someone who is, like maybe this lady up on stage right now, and she can probably tell us everything about every single microbe on Earth. Well, I'm here to tell you, I can't. And it's not just because I'm an imperfect scientist, although I am an imperfect scientist. It's because nobody can tell you, because we still don't know what the majority of microbes on this Earth can do. So back in up until maybe the 1980s, say, a microbiologist could be forgiven for thinking that maybe she was starting to get a handle on all the different types of microbes on Earth. Because microbiologists for years are absolute wizards at getting a vast and beautiful array of microbes to grow in cultures. From them we've learned that microbes can eat really weird stuff like oil or tree bark or methane, and they can breathe things that don't sound like things to breathe to us, like sulfate, iron, even carbon dioxide from the atmosphere. But we've known all these things from cultures. But in the 1980s and the 1990s, we learned that we had sort of a big microbial revolution that changed the way we think about microbiology. We discovered two big things. The first thing that we learned is that we started finding microbes in strange places like hot springs and hydrothermal vents and glacial ice and individual crystals of salt in the deep sea. It turns out that environments that seem like inhospitable death chambers to our fragile and energy-hogging human bodies, to a microbe is like a comfy bubble bath with rubber duckies. Microbes live in some pretty weird places on Earth, so that's the first thing. The second thing that we learned is that we learned how to get DNA directly from the environment and sequence it and figure out what microbes are there without having to grow them. And we found that we were missing a ton of them. An analogy for this would be like if you imagine how many stars in the sky people could see on ancient Earth. So people estimate this with their naked eyes. People estimate this to be about 5,000 stars. But of course, when humans developed fancy telescopes, we now know that there's more like 10 to the 25 stars in the universe. That's 10 million billion billions. It's a lot. So the microbial revolution has been amazing because it's shown that we share the Earth with a lot more different types of microbes than we ever thought that we did. So that's nice. But also, the microbial revolution has affected all of our lives on nearly a daily basis. In a hot spring bacterium called Thermus aquaticus, scientists were able to isolate an enzyme called Taq polymerase. This enzyme does one thing, and it does it well. It takes one strand of DNA and makes a whole ton of copies of it. And this technology has allowed us to learn almost everything that we've learned about the genes involved in every human disease. Cancer, AIDS, asthma, bacterial infections. Everything that we know about these devastating diseases comes through Taq polymerase for the most part. So to a biomedical scientist, Taq polymerase is like a hammer is to a carpenter. So where will the next great discovery be from these exotic microbes? It's possible that it could be happening right now, right here in Mexico. So it turns out we're all started up. No, yeah, that's working. No, did I have control over that? Should I point it at it? Oh, back up. Okay, so we're all here in Puebla, Mexico, but right now my colleagues Andreas Tesca and Javier Caraveo Patiño are floating in the Sea of Cortez, and they're working on hydrothermal vents that are down in the seafloor, in the Sea of Cortez. And there's a rift, there's a tectonic rift that runs up the center of the Gulf of California, and this superheats the seafloor and causes there to be a vast and beautiful landscape of colorful microbial mats and giant tube worms that are as tall as I am, that don't have mouths and they don't have stomachs. And the way they get away with this is that they're full of microbes that harvest the energy from deep chemicals coming out of the deep earth and turn it into food for the worm itself. So Guaymas Basin, don't pronounce the G, Guaymas Basin, which is where this area is called, is as beautiful as Yellowstone National Park. But Yellowstone National Park has about 5 million visitors per year, whereas Guaymas Basin has 20 every 5 to 6 years. The reason is that it's really hard to get to. You have to go in a submarine. And there it is. It might advance past it because I pressed it twice. So this is Alvin submersible. You can't go in any submarine because you need one that can handle a mile worth of water over top of you without crushing like a tin can. And I've been lucky enough to go in this submersible that's out there working right now. This is a picture of me getting on board the submersible, and this is me inside the submersible. This is coming undone. Okay, so even for a hydrothermal vent, go to the white screen. Even for a hydrothermal vent, Guaymas Basin is exciting because unlike a lot of places on the seafloor, it sits next to this huge land mass of Mexico. And all the soils and sedimentation come running off of the land, and they build up right on top of that intense deep earth heat. And that cooks the carbon in the system and creates lots of different types of food sources for the microbes that live there. So it could be that the types of microbes that we find in Guaymas Basin are not present anywhere else on Earth. So, I think so. Yeah. So, will something as exciting and useful as Taq polymerase be found in Guaymas Basin? Maybe. Are the microbes there going to give us clues about what potential ways to battle climate change, the effects of climate change? That's entirely likely. But with a little, it's going to take a lot of luck, and it's going to take a lot of diligence. Perhaps scientists can work out ways to find out how these microbes can help us to maintain the life support system of Earth. And maybe we'll find out that there are ways that microbes can help save us from ourselves. Thanks so much for listening.